Good morning. This lesson is for my Honors Integrated 1 class. This is lessons 4.2 and 4.3, but before I get started, I want to say I hope that everybody is doing okay out there. Let's go ahead and jump into our goals today. We have two goals. Our first goal is going to be to define arithmetic sequences and finding the common difference. Our second goal is going to be writing explicit rules and simplifying them. So, pretty simple lesson. A little bit more vocabulary based, but again, try and if I write it, you write it, and I would recommend adding little comments that you might pick up on as I work through this lesson. All right, so let's go ahead and jump into our first goal, defining arithmetic sequences and finding the common difference. Remember, if I write it, you write it. Arithmetic sequences are sequences where consecutive terms change at a constant rate. The constant rate is called the common difference. Remember, sequences are events that happen in order. First event, second event, third event. And so I have two examples on the board of arithmetic, or of sequences. I have a first, a second, a third, and a fourth term. Again, 4 terms. But we're going to see how the terms change. Remember, the terms are the output values. So 8 turned into 13 by adding 5. 13 turned into 18 by adding 5. And 18 turned into 23 by adding 5. So we will call this an arithmetic sequence because there's a constant, the consecutive terms change at a constant rate. So consecutive means one after the other, right? 19, 20, 21, those are consecutive numbers. So these are changing at a constant rate. They're changing at an increase of 5. So this is arithmetic. And the common difference that's going to be 5 plus 5. Okay, let's look at example 2. 2 turns into 4 by adding 2. 4 turns into 8 by adding 4. Right here, I know right off the bat that this cannot be arithmetic because the change is not constant. The amount that term 2 needed to turn into term 3 was 4. That doubled what the previous 2 terms needed. So this one is not arithmetic. Okay. So I want to check off the first goal. I think again it's a pretty simple goal here. All right. So let's move on to our second goal, and it's going to be writing explicit rules and simplifying them. So I have the definition of an explicit rule. It is an equation that represents a sequence, meaning that if you plug in a position number, you will get that term. So, for example, if I had an equation that represented this table, if I plug in 2, I'm going to get 13. That's what this is saying down here. And that's something that we're going to want to do because we want to make sure that that our equations that represent the table are in fact true. So I'm going to erase this. I apologize. I don't like to rewrite while I'm teaching. I can't imagine anything more boring than a math lesson where you're watching the teacher write notes on the board. And again, make sure if I write it, you write it. These are how the notes should be written. This is the book that we are creating this semester. So let me jump into just a random example. All right, this example is going to be an arithmetic sequence. So I'm going to create it in such a way that I know for sure it's arithmetic. So there's my n, there's my a sub n. I'll make up my first term as 25. My second term, we'll say 20. My third term will be 15. And we'll just continue to the fourth term. That'll be 10. All right, and this pattern continues. The common difference on this one is going to be minus 5. Email. So excuse that. So the common difference is minus 5. I'm going to take this table and I'm going to write it like this. It's just easier, I think, for this lesson to see the table written vertically. So my first term is 25. My second term is 20. My third term is, what is it? It's 15. My fourth term is 10, and then the pattern continues. All right, so remember, when we write equations, we want repeating values, right? We want repeating values. It's really, really important in creating an equation, so we want repeating values. All right, so I'm going to rewrite this, and I'm going to rewrite every line or every row using 25 because I want to create a pattern here. So, and I'm sorry I'm dropping this a little bit lower, but my first term is 25. My second term, remember I want to use 25 in every row. So my second term is going to be 25 minus 5, right? And then my third term is going to be 25 minus, I need two 5s, so it's going to be minus 5 times 2. My fourth term is going to be 25 minus 5, 3 5s, right? To go from 25 to 10, I need to take away 3 5s. So 25 minus 5 times 3. All right, so I now, based on the previous lesson, when I'm writing an explicit rule for a sequence, we would then replace whatever number I'm multiplying by n. So we're going to take a shot at this explicit rule as a sub n is equal to 25 minus 5 times n. All right, and so if this is a correctly written equation that represents this table, I, for example, should be able to plug in 3 and get 15. I should be able to do that. All right, so let's see here. So I'm going to try and see if my third position number is in fact 15. So it's 25 minus 5 times 3. This becomes 25 minus 15, and this is equal to 10. I didn't get 15. I made a mistake on my explicit rule, and I made it on purpose. And the way that I made it is I didn't have repeating values. Remember previously, this number would be the same as this number, and this number would be the same as this number, and this 1 would be the same as that. So there's an issue here. I'm off. This equation, which I know how to write from the previous lessons, doesn't work. And this is why for some of you I really suggested, hey, don't just memorize how to write the equation. Learn how to do this, because this process is going to allow us to write equations for any situation. So I'm going to erase this real quick, and I'm going to show you how we fix this. Okay? So one of the things in mathematics that I've learned and I rely on is you can be creative with how you write values. Okay? And so I want to talk about ways that I can write the value 1. I could write the value 1 as 1. I could write the value 1 as 5 over 5. I could write it as 4 minus 5. And so what I'm trying to highlight here is I can represent values in many ways, but it's still the same value. And so remember, we need repeating values. So I'm going to write the value of 1 so that it uses the number 2. So let me show you how we're going to do this. It's a pretty simple little trick. I'll give you guys a second. We're going to hit pause and see if you actually generate the correct value. All right, so 1 and 25. I need to use a 2. on this line, but I need the value of 1. So how do I get the value of 1 using the number 2? Well, the way that we're going to do that is we're going to write it like this: 25 minus 5, and then I'm going to go 2 minus 1. I still have the value 1, but now I have my repeating values. So I need this value to be 2, but I have to use a 3 on the next line. So that means it's going to be 3, and then 25. So the way that I write the value 2 using a 3 is going to be minus 5. And so instead of saying 2, I'm going to say 3 minus 1. Now I have the repeating. Okay, let's do that again for this. So the fourth position is 25 minus 5 times 3. But I can't use the number 3. I have to have 4 repeating right here. So how do I get the value 3 using the number 4? I write it like this: 25 minus 5 times 4 minus 1. All right, and let me make sure that I'm still in the video finder here. Okay, good, I'm still in the video finder. So remember, when my numbers repeat, this value is still 3, but now I have the 4 in there. This value is still 2, but now I have the 3 in there. This value is still 1, but now I have the 2, right? Then I can even write it like this: minus 5, then 1 minus 1. This value is 0 because I'm not subtracting a 5, right? And I have my repeating 1. All right, so the explicit rule for this is going to be a sub n equals, remember we replaced the repeating with the x, so let me write that. Or an n. So this pattern repeats to the nth term. So I'm not being constant with this, but that's okay. So it'll be 25 minus 5. I replace my repeating numbers with an n, so this becomes n minus 1. Okay, so this should generate this table. And I'm running out of room here, so I'm going to just kind of use what little space I have left, and I'm going to say a sub n equals, and I'm trying not to block this 25 minus 5n minus 1, but I know I'm just going to do this real quick. So this becomes 25 minus 5n plus 5. Okay, I can put these together, and I get a simplified explicit rule, which is a sub n is equal to 30 minus 5n. And so, for example, now if I plug in a 3, I get 30 minus 5 times 3, that's going to be 15. So 30 minus 15, that's going to get me my third term, which is 15. And now my explicit rule generates this table, and it's correct. And again, the problem was these numbers aren't repeating. And so we have to get creative with how we write them so that I can get a repeating number in there. So it's a little goofy on this. This is going to take some practice to wrap your mind around. But again, I want to say that I did hit the goals here. The first thing I did talk about was what an arithmetic sequence was and find the common difference. Remember, they're growing at a constant rate. The explicit rule, what happened today was when we just wrote it out, it didn't work. It was off a little bit. I'll give you a little comment. It was off by 1, right? This was supposed to make 15, but I got a 10. So maybe that'll help you understand why I subtracted 1, right? So I had to create a way to get a value that had my repeating number in here. So it's a little bit tricky. I'm sure I'm gonna have some questions on this, but again, that's the lesson. Again, I hope everyone's doing all right out there. Bye-bye.